Welcome back, focused learners. I'm absolutely thrilled to have you here for another explainer. Because today, we're tackling one of the most fascinating and honestly urgent mysteries of our time. Think about it. We live on this breathtaking blue planet, right? A world totally defined by its oceans, rivers, and ice caps. And yet, despite all this literal abundance, we're facing a desperate global thirst. I mean, how does that even happen? And more importantly, how do we solve it? So today, we're going to unpack the great water paradox. We'll look at the data, the human impact, and some incredibly ingenious solutions from both our past and our present.
Now, you've probably heard this famous line before. Water, water everywhere, not a drop to drink. It perfectly hits the nail on the head regarding the fundamental contradiction we're dealing with. It's a super well-known fact that 3/4 of the Earth's surface is covered with water. But here's the catch. Only a wildly small proportion of that is actually fresh water that you and I can use. The vast majority of it is locked away in oceans, way too salty to sustain our crops or, our bodies. The fresh water we do rely on is mainly obtained from surface runoff and groundwater.
Okay, let's dive into this, because this is where the mystery really deepens. That fresh water we just talked about, it's continually being renewed and recharged through the hydrological cycle. All water moves within this cycle, which ensures that technically, water is a renewable resource. It really shouldn't run out. So we have to ask ourselves a pretty critical question here. If the world is covered in water, and water constantly renews itself, how on earth are countries and regions all around the globe suffering from crippling scarcity? And actually, what's even more alarming, why are the projections looking so incredibly grim for our immediate future?
Well, I want to anchor the immense stakes of our narrative right here. 2 billion. It's predicted that by the year 2025, nearly 2 billion people will live in absolute water scarcity. Just let that sink in for a second. That is a staggering portion of humanity. This isn't some distant theoretical problem for, future generations to figure out. It's a massive structural crisis happening right now. And understand exactly how we got to this number, we kind of have to rethink everything we assume about what water scarcity actually looks like.
Section 1. Defining water scarcity. More than just deserts.
So when we talk about water shortages, our brains almost immediately jump to drought-prone deserts, right? We imagine women carefully balancing earthen pots known as mutkas, traveling these incredibly long, exhausting distances just to get enough water for the day. And that is the classic definition, quantitative scarcity. Basically, simply not having enough physical volume of water because of low seasonal rainfall, droughts, or just overexploiting the groundwater. But qualitative scarcity, that's an entirely different beast. This is a situation where a region might actually have ample water resources to meet the needs of its people, but that water is essentially useless. Why? Because it's heavily polluted. We're talking domestic and industrial wastes, chemicals, pesticides, and agricultural fertilizers. It's totally abundant, but completely hazardous for human use. To really see this paradox in action, just consider a city like Kolkata. Imagine a situation where a boy is forced to collect drinking water, while the city around him is completely paralyzed by a record 180 millimeters of incessant overnight rain. The streets are literally flooded, vast areas are completely underwater, traffic is a nightmare, and yet, amid all this excess water, everyday citizens are still struggling to find pure, safe drinking water. A city can be literally drowning in rain, yet fundamentally thirsty. It's crazy.
Section 2. The human impact, overexploitation and industry.
So if the water is there but we can't use it, we have to investigate the prime suspects behind this mystery. And well, unfortunately, the suspects are us. Our relationship with water is just incredibly complex. Water has a real dual nature. It gives life, obviously, but it can also take it away through devastating floods. And while we absolutely rely on it for basic survival, to drink, cook, and wash, our modern industrial infrastructure demands massive amounts of it for entirely different reasons. Factories need it for manufacturing, and specifically for cooling these massive factory machines. Add to that, the factory itself runs on power supplied by a hydel or hydroelectric power plant. Basically, our modern lives demand water at every single level of consumption.
Take post-independent India, for example. The country witnessed intensive industrialization and urbanization. And sure, this created vast opportunities, absolutely. But the ever-increasing number of industries, including huge multinational corporations, has exerted unbelievable pressure on fragile freshwater resources. And honestly, it's not just heavy industry. Look at the rapidly multiplying urban centers with their huge, dense populations. If you examine modern housing societies or colonies in big cities, you'll find that most of them have their own independent groundwater pumping devices. It's like a free-for-all. Everyone is individually pumping from the exact same fragile shared aquifer, which naturally leads to rapid overexploitation and severe depletion.
Section 3. Multipurpose river projects, the modern approach. Okay, so humans caused the problem through rapid expansion. How have we historically tried to manage it? Well, generally we rely on large-scale infrastructure, like dams. By definition, a dam is a barrier across flowing water that obstructs, directs, or retards the flow. It often creates a reservoir, lake, or impoundment. And actually, fun fact, the word dam usually refers to the reservoir itself rather than the physical structure we always picture. Modern marvels like the Hirakud Dam usually have a spillway or weir for water to flow over. They're massive, awe-inspiring feats of engineering meant to regulate our pretty erratic water supply.
Naturally, governments are heavily prioritizing these massive, nationwide management solutions. The government of India, for instance, launched the Jal Jeevan Mission, or JJM, and the sheer scale of the goal here is deeply ambitious, but so necessary. They want to enable every single rural household to get an assured supply of potable, piped water. Specifically, they're aiming for a service level of 55 liters per capita per day regularly and on a long-term basis. This kind of reliable access is absolutely vital. It safeguards public health, ensures food security, and helps protect our natural ecosystems from the ecological crisis of overexploitation.
Section 4. Ancient rainwater harvesting, the hidden heroes. Now, while massive dams and nationwide pipe networks are completely crucial, they aren't the only way. Many experts believe we need viable socioeconomic and environmental alternatives. And this is where we look to the past. Long before modern machinery, ancient populations in India possessed this in-depth, almost localized genius regarding rainfall regimes and soil types. It is truly awe-inspiring. They didn't try to fight nature, they adapted to it brilliantly. For example, in the hilly mountainous regions of the western Himalayas, they built diversion channels called gulls or kols for agriculture. Over in the floodplains of Bengal, they developed inundation channels to irrigate their fields. And in arid and semi-arid regions, they actually converted agricultural fields into rain-fed storage structures, things like the Khadins in Jaisalmer and Johads in Rajasthan, which allowed water to stand and naturally moisten the soil. And this brilliantly illustrates one of my absolute favorite methods. In traditional houses across Rajasthan's semi-arid regions, places like Bikaner, Phalodi, and Barmer, you'll find this ingenious system for storing drinking water. They traditionally featured an underground tank, or tanka. But we're not talking about small buckets here. These tankas could be as large as a big room. I mean, one household in Phalodi literally had a tank over 6 meters deep and 4 meters long, built right inside their main house or courtyard. So here's how it works. When rain falls on the sloping rooftops, they don't just collect it immediately. They cleverly let the first spell of rain wash the roof and the pipes completely clean. That first bit isn't collected at all. Only the pure rainwater from the subsequent showers travels down the pipe where it's stored safely in the underground tanka. This pure rainwater, which is locally referred to as Palar Pani, is considered the absolute purest form of natural water. It's an extremely reliable drinking source for when everything else just totally dries up in the summer. And get this, some people even built underground rooms right next to the tanka, because the stored water would keep the adjoining room wonderfully cool during the intense summer heat. How smart is that? Section 5. Conserving our future. Blending old and new. But look, this isn't just a history lesson. The Great Water Paradox requires us to bring this ancient wisdom right into the 21st century, and we are actually seeing some incredible modern successes on this front. For example, Tamil Nadu became the very first state in India to make rooftop rainwater harvesting structures compulsory for all houses across the entire state. This is such a brilliant example of taking an ancient, super sustainable practice and turning it into a viable, legal, structural mandate for our future. It proves that water conservation isn't just about pouring concrete from massive dams, it's about micro-level management right at the household level. And when you actually mandate this at a household level, the results are just astounding. To give you an idea of the scale, depending on the specific setup, a single household practicing efficient rooftop rainwater harvesting can net an amount of 100,000 liters of water annually. Literally, 100,000 liters, just from capturing the rain that falls on a single roof. When you multiply that by millions of homes in our rapidly multiplying urban centers, you start to see a real, tangible solution to that terrifying 2 billion scarcity number we talked about earlier. So we've seen that the Earth actually has enough water, provided we respect the hydrological cycle, prevent qualitative pollution, and capture the rain before it runs away. The mystery of the Great Water Paradox isn't some unsolvable puzzle. It's a management challenge, one that requires both grand government missions and smart, localized rooftop solutions. So I'll leave you with this to think about. Knowing the immense power of simple conservation methods, how will you change your own footprint to solve the great water paradox in your community? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I will see you next time.